So this is our next type, logarithmic differentiation. Okay, so I have written here when to use log. So in our previous video, if you remember, we had taken log on both sides. So there are some problems where we have to take log on both sides. So in this exercise we will see such problems, and you will come to know where we have to take log. So before that I have written three terms here, y equal to x raised to a, y equal to a raised to x, and y equal to x raised to x. So if you want to find derivative of all these three terms, x raised to a can be differentiated using x raised to n formula. A raised to x is our formula only, so you can find derivative of a raised to x using this a raised to x formula. And to take derivative of x raised to x, you cannot use x raised to a formula as well as a raised to x formula, because in both of these cases there is a constant in the power or in the base. But here in this case only variable is there in the power as well as in the base, so we cannot use x raised to n formula as well as a raised to x formula. So now we will see then how to find derivative of x raised to x form terms. So now we will see our first example, y is equal to x raised to x. So here we will take log on both sides. So now after taking log, you will see that problem will be very simple to solve. And if you don't take log, then there is no other way to differentiate this problem. So taking log on both sides, derivative of log y equal to log of x raised to x. This x we can write here in the denominator using log x raised to n is equal to n into log x formula, third formula of logarithm. Okay, so we will write this x here, x into log x. Now we will find derivative of both sides. Okay, differentiating with respect to x. Derivative of log y will be 1 upon y multiplied by dy by dx. So now at least you should know, up till now we have seen many problems like that, why we write dy by dx separately and we don't write only 1 upon y for derivative of log y, because this is not a simple function, this is composite function. If it would be log x, then we would have written 1 upon x, but this is one log y, therefore we have to first take derivative of log and then take derivative of y. So derivative of log is 1 upon y multiplied by derivative of y, that is dy by dx. And this right hand side term is x into log x. So here we see multiplication, therefore we have to use u into v formula of derivative to differentiate this. So using uv formula, that is v multiplied by derivative of u plus u multiplied by derivative of v. So our u is x, so and v is log x. Log x multiplied by derivative of u, that is x, plus x multiplied by derivative of v, that is log x. So taking derivative of x is 1, taking derivative of log x, that is 1 upon x. So x can be cancelled here, so it will be only 1, and log x into 1 is log x. So here now if you want to write only dy by dx term on left side, then we will write dy by dx equal to y. This y from left side we will write on right side here in the numerator, y into 1 plus log x. So final answer, if you see our question, it is y equal to x raised to x. Therefore this we can substitute here in our final answer, y as x raised to x into 1 plus log x. So this is our final answer, dy by dx equal to x raised to x multiplied by 1 plus log x. We will see next example. Our second example is y equal to sin x raised to x. So this example is not very much similar to previous problem. Here the same thing is, there is term of x in the power as well as in the base, but not this is not x raised to x, but this is of f of x raised to x form. So here also you should note that for all such problems where in the base as well as in the power there are functions of x, it may be only x or maybe function of x, you have to take log on both sides, and similarly you have to differentiate like our previous example. So taking log on both sides, log of y will be log y equal to log of sin x raised to x. Okay, so using again log x raised to n formula, that is n into log x, we will take x here in the uh, here down x into log of sin x. So we have to find derivative differentiating with respect to x. So derivative for left hand side will be 1 upon y dy by dx, as this is a composite function, and here it is multiplication, therefore we have to use uv formula. And while differentiating using uv formula, for this particular term we have to differentiate using composite technique, because this is not a simple log x, this is log of sine, that is log of f of x form. So using uv, first we will use uv formula, v that is log of sine x plus derivative of x plus x multiplied by log of sin x, this is v term. Okay, so now take derivative of x, that is 1 plus x multiply by derivative of log of sine. So first you have to take derivative of log, that is 1 upon sin x, multiply by derivative of sine, that is cos. So in the next step we have to find derivative of sine, that will be cos. So log of sin x into 1 is log of sin x plus x multiply by cos multiplied by sine. Okay, so cos and sine we can put together to cot x. So our left side is log of sine x plus x into cot x. So if you take 1 upon y from left side, and if you take it to right hand side, it will be y multiplied by log of sine x plus x cot x. And y from the main question, again like previous problem, y from main question, value of y is sin x raised to x, you can put here as sin x raised to x multiply by log x plus x cot x. So this is the solution for this. Next example, our third example. Here the problem is more complex than previous two problems. X plus 1 raised to e raised to x and tan x raised to x. So here we can see that in the numerator as well as in the denominator, both terms are in x raised to f of x raised to f of x form. Okay, so this is, it seems difficult, but this is also simple problem if you take log. So taking log on both sides, y left side is y, so taking log of y and log of this whole thing. So here we have to use log x upon y, that is log x minus log y. This is our second formula of logarithmic properties. Log x minus log y is log x upon y. So in reverse order we will use this formula. So this term we can write as log of x plus 1 into e raised to x minus log of tan x raised to x. So subtraction. Okay. So again like our previous problems, this e raised to x we can take down here using log x raised to n formula. This x you can take here. Okay. So using logarithmic properties, we have written like this. Now we will differentiate. While differentiating, you should note that here this is in UV form. So therefore you have to use UV formula for this, as well as you have to use UV formula for this also. Simultaneously we will take derivative of both of these terms. And while taking derivative of this term as well as log of tan, we should note that these are not simple terms, these are composite terms. So here we have to take derivative according to our composite technique. So differentiating with respect to x, derivative of y, the left hand side term log y, 1 by y into dy by dx. This is derivative of log y. Okay, 1 upon y into dy by dx equal to using uv formula. So this is u, this is v. Log x plus 1 multiply by derivative of e raised to x plus log x plus 1 into derivative of e raised to x plus e raised to x multiply by derivative of log x plus 1. So this is u, this is v. Using uv property we have written this. This is for our first part. Minus for second part, uh, this is u and this is v. So log of tan x v multiply by derivative of x plus x multiply by derivative of log of tan x. So here you should note that twice we have used uv formula. Okay. So for first term, here we have to take derivative of e raised to x and write here as e raised to x. Then this term log x plus 1. So we have to take derivative of log x plus 1 as 1 upon x plus 1. Why? Because this is composite function, and multiply by derivative of x plus 1. So this is log f of x. So first take derivative of log, then take derivative of x plus 1. Okay. And for the second part, derivative of x will be 1 here, and derivative of log of tan will be 1 upon tan multiply by derivative of tan. So using derivative of log as 1 upon f multiply by derivative of tan, that is sec square. So in the next step we will see that. So log x plus 1 from here e raised to x plus e raised to x 1 upon x plus 1, and derivative of x plus 1 will be 1 into 1 plus 0. So that will be 1 only here. And in the second part, log of tan x into 1 is log of tan x plus x multiplied by tan x. So x upon tan x multiplied by derivative of tan will be sec square. So here we have completely taken derivative of right hand side. Now 1 upon y. 1 upon y. This y we have to take on right hand side like previous two problems. So we will write dy by dx only on left side, and on right side we will write y multiply by this whole thing we have written here. And y, you know now that y is question only. So this whole the main question y equal to x plus 1 in raised to x e raised to x upon tan x raised to x. We will substitute here. Okay, we will substitute here, and the whole other term derivative term we will write here. So this is how we have to find derivative. So thank you.